Hello, everyone. My name is Peter Bose. I'm here with Vision Analytical, and we're running some sodium ion battery materials using the particle insight. So the first sample we're running is one that's apparently very common called Prussian blue. At the end of the analysis, what we've been able to do is look at different classifications of particles. So, for example, in this case, we're looking at some of the larger irregular particles. You can also look at some of the smaller irregular particles, and then we have two different classifications as well on round, large round and small round. So the classification is just one of the features that allows you to categorize all the subpopulations in your sample. The next sample we have here is called Prussian white, and it is very white. That's one thing I will admit. And at the end of the analysis, again, we look at the different classifications, just trying to determine the different classes of particles and how many and what percent of the total is in the sample. And what we'll do at the end is we'll do some comparisons of the, let's say, the Prussian blue and the Prussian white, and to see if we can actually see some differentiation between the two. Now we're running the sodium cobalt oxide sample, and when we look at the results, we see that there is a little bit more presence of stick-like particles. So at the end of the analysis of all the different four samples, we're going to do a comparison. But again, here we go through the different comparisons and look at the classifications of the different particles. But definitely, when you look at some of the irregular particles, they are more stick-like. And we should be able to see that as a comparison of all samples, and we look at that by aspect ratio. And we'll be doing that at the end of the of all four samples. For this sample, we're going to be showing a number weighted distribution, but then we're going to switch over to a volume weighted distribution. So the volume weighted distribution is something that you would normally see with other techniques such as laser diffraction. Dynamic image analysis has the ability of showing both a number weighted distribution as well as a volume weighted distribution. So we have that benefit of having both. At the end of the analysis, just like the other three samples, we're also going to look at the different classifications of particles based on their size and their shape. Here we can definitely see a difference in shape because there are some stick-like particles or much more stick-like particles than the previous samples. So we're going to be able to do a comparison and a contrast between all of these, and I would suspect that the sodium manganese oxide samples are going to have a much higher aspect ratio than the other samples. And I'd also like to point out that we are able to get thumbnail images all the way down into the single micron range. Now we're going to do some comparisons. So we opened up the four samples right here, the sodium cobalt, sodium manganese, Prussian white, Prussian blue, and we're looking at just a comparison of size. So we're going to look at size, mean size, and for now we're going to look at number weighted distribution. So when we look at all the samples, we'll see a comparison here. We can spread this out. And here we could clearly see that there's one big outlier here, which is the blue sample, blue being the second sample, which is the sodium manganese. The sodium manganese, assuming particles are round, again, equivalent circular area diameter is assuming that the particles are round, and it's going to be the closest comparison to other particle size methods. We can definitely see that that sample has a great, much higher population of particles below a micron, and definitely a smaller population of on the higher side, which is the 2 to 10 micron range. However, and again, the other one, especially this purple one, is number four. The Prussian blue definitely also has a peak here and just below a micron. But then the other ones on a number weighted distribution seem to be somewhat close here. But now when we look at a volume weighted distribution, we could see that on a volume weighted distribution, kind of hard to tell differences. The only one that looks a little different here again is the Prussian white. That seems to have maybe some smaller particles than everybody else on a volume weighted distribution. Let's go back to number. That's the green one. So Yeah, so it looks like it does have a good comparison here with other ones, but when you look at the volume weighted distribution, the only outlier is going to be uh, possibly the purple one, which was the Prussian blue. But definitely there's some peak here. This is probably one large particle, and we're going to go investigate that in a minute. In addition to looking at number and volume weighted distribution comparisons, I always like to look at differences in shape. So I like to look at possibly circularity. So when I look at circularity, I do comparisons in circularity. We could see, spread this out a little bit. We could see that the blue one, again, blue one being the manganese oxide, is a bit different, has a little bit lower value here. So one being very round. Looking at circularity, I also look at smoothness, and we could look at opacity as well, and aspect ratio. So smoothness, this is just the irregularity of the perimeter of the perimeter of the shape. So we can look at definitely some differences there. We look at aspect ratio as well. That's another one, another good comparison to look at, and we could definitely see that aspect ratio wise, three. So it looks like the Prussian white and the Prussian blue have similar aspect ratios, which is interesting. Um, and then also we could look at opacity, how dark the particles are. See, we see something different here. And definitely some differences. So it looks like the fourth sample, being the Prussian blue, is much darker. So it's a darker particle. So that's one other way of differentiating samples. I'd like to see what that one peak was real quick. So going back to the Prussian white sample, we did see, not on a number weighted distribution, but on a volume weighted distribution, we saw that one peak, which is about a 20 micron particle. Uh, just to look at how many there were, we can actually zoom in and see how many there were. And it looks like it was only just one particle. So just out of curiosity, I just wanted to see what that one particle was, so we can go to our dashboard, and there it is. It's 20 micron particle. So I hope this helps. This is a really good experiment that we did, comparing four different types of sodium ion battery materials, and definitely some differences in shape from what I've seen with lithium ion.